In section 1.2, we will review properties of exponents and radicals. We will begin with some basic examples to remind ourselves of how to work problems. Our first example asks us to find 4 to the third power. We want to remember that 4 to the third is the same as asking us to multiply 4 times itself 3 times. So 4 to the third is equivalent to 4 times 4 times 4, which is equal to 64. Our next example asks us to take the quantity -3 and square it. Notice the placement of the parentheses. So this is asking us to take -3 and multiply it by itself twice. So -3 times -3. We know that a negative times a negative is a positive, and 3 times 3 is 9. So the answer will be positive 9. Our next example, while it appears similar to part B, it's actually quite different because we do not have the parentheses here. Remember that your order of operations asks you to do your exponents first before you do multiplication. So you might want to think about this example as being the same thing as -1 times 3 to the fourth. The fourth power goes with the 3, and the negative is separated from that by multiplication. So we know that 3 to the fourth is 3 times 3 times 3 times 3. And let's go ahead and calculate this part. 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So we have a -1 times 81, which will give us as a final answer -81. Our next example asks us to find negative, and in parentheses, -2, raised to the third power, times 5 squared. So again, let's begin with our exponents and simplify on the exponents. So -2 to the third is going to be the equivalent of -2 times -2 times -2. And we'll keep that negative on the outside of the parenthesis. And then 5 squared is going to be the same thing as 5 times 5. So working on our multiplications, -2 times -2 times -2, that's going to be a -8. And 5 squared we know is 25. Now, when we multiply a negative on the outside of the parenthesis with the negative inside the parenthesis, that term becomes positive. A negative times a negative is a positive 8. And we're multiplying by 25, which gives me a final answer of 200. Our next example asks us to multiply x to the third times x to the fourth. X to the third is another way of asking us to do x times x times x. That is x to the third. And then we're going to multiply times x to the fourth. So x to the fourth will be x times x times x times x. So we have our 3 x's here for x to the third. We have our 4 x's here for x to the fourth. When we multiply together, how many x's do we have total? We have 7. So x to the fourth times x to the third is equal to x to the 7th power. The next rule that we want to remember says that a to the 0 is equal to 1. Now, essentially what this is saying is that for any number that we raise to the 0 power, the answer is equal to 1. So if we had 5 to the 0, that's equal to 1. Or 10 to the 0, is equal to 1, or negative 8 to the 0 equal to 1. Any number that we raise to the 0 power is always equal to 1. We also have a rule that helps us to deal with a negative exponent. And so look right here, it says that a to the negative n is the same thing as 1 over a to the n. So if we have a problem that has, say, 5 to the negative 3 in it, then what this statement is saying is that if we write this as a fraction, and we take this 5 to the negative 3, and instead of having it in the numerator of the fraction, and right now it is in the numerator of a fraction because it's over 1, if we move it down to the denominator, then the exponent becomes positive. So what we're saying here is that 1 over 5 to the third, what we have right here, is the same thing as 5 to the negative third power. All right, so if we had had 7 to the negative 2, think about how we would write that so that it has a positive exponent. We would write it 1 over 7 squared. Now, the flip side of this is if you had a problem that had, say, 1 over a to the negative fourth, and again, your goal is to write it with a positive exponent, you can take this a to the negative fourth and pull it up to the top, and the exponent will become positive. So a good rule of thumb to remember is that if you want to change an exponent from negative to positive, you simply have to move it either up or down in the fraction. So a lot of times we'll say that as you cross this line, the fraction bar line, the sign, whether it's positive or negative, on your exponent will change. So if I move the a to the negative fourth to the top, it becomes positive. If I move this 5 to the negative 3 down, it becomes positive. And we'll look at some examples of that right now. All right, so let's say that our first problem is y to the second over y to the seventh. Now, let's remember what we know about what this expression says. Y to the second means y times y, 2 of them. And y to the seventh means that we have 7 of them. So y times y times y times y times y times y and times y. So we have 2 y's in the top and we have 7 y's in the bottom. And if you notice in terms of canceling now, we can cancel one of them in the top with one of them in the bottom. We can cancel another one in the top with another one in the bottom. And look at what that leaves us. That leaves us 5 y's in the denominator. And what does it leave us on the top? It leaves us, at first glance, you look at it and you might think it leaves me nothing, but actually remember that there's always a coefficient of 1 sitting in front of these things. So it leaves you a 1 over y to the fifth. And if I wanted to write that not as a fraction, but just as an exponent, then remember that you could bring the y to the fifth up to the top, and when you cross that middle line, remember that your exponent becomes negative. Okay? All right, so let's look at part B. So part B says 6x squared over negative 3x squared. And again, let's kind of expand this thing out. So 6x squared is 6 and 2 x's. And negative 3x squared is negative 3 times x times x. And so look at what cancels here. You have an x in the top and an x in the bottom. You have another one that'll cancel. And so actually all of your x's go away, and you're left with 6 over negative 3, which we know reduces to negative 2. Okay, what about our next one? What is 5 to the 0 power? Remember that we said anything raised to the 0 power is equal to what? Correct. Anything raised to the 0 power is equal to 1. So this part is going to equal 1. So we have 1 times 5 to the negative 3. Now, we know that 1 times anything is going to be that thing that we multiplied by. So the answer to this is 5 to the negative 3, but we need to get it simplified. So remember that if it's a negative exponent, we want to make it a positive exponent, we need to move it either up or down depending on where it's at. And this is currently in the top part of a fraction, so we need to move it down to the bottom. All right, so that makes it a positive exponent. And then what about 5 to the third? 5 to the third is the same thing as 5 times 5 times 5, and we can use our calculator to see that that is equal to 125. All right, let's move on. Part D asks us to simplify 1 over t to the negative 3. So again, remember that if we have a negative exponent like we have here, we want to make it positive, we simply need to cross that middle line, either moving it up or down depending on where it starts out. So t to the negative third, I'm going to bring it up to the top, and it will become positive, and we're done with that one. All right, our last one here, x squared times y in parentheses raised to the third power. And so remember that when we raise something to a power, it means that we're going to take that expression and we're going to multiply it by itself 3 times. So we have x squared times y times x squared times y times x squared times y. And so let's regroup this. We have x squared times x squared times x squared. That puts our x's together and takes care of those first 3 terms. And then we also have a y times y times y. So how many x's do we have all together? Well, remember that x squared is really, this x squared is just x times x. And this x squared would be x times x. And this x squared would be x times x. So we have 1, 2, 3, 4, 5, 6 x's. And how many y's do we have? We have 3. And so our final answer will look like x to the 6th, y to the 3rd. Now, this slide basically summarizes some of these rules that we've already talked about and gives us kind of an easier approach in some cases to solving the problems. All right, the first 2 properties that we have listed right here deal with a rule where we are multiplying 2 expressions that have the same base. Okay, they both have the a, and we have different exponents. And so our rule says that if your bases are the same, you have the same a part, then you can add those exponents together. Like if we had a problem 3 to the third times 3 to the negative 1, they both have a base of 3. So you can see here that we're adding those 2 exponents together. 3 plus negative 1 gives me a 2, and 3 squared is going to be equal to 9. All right, we have a similar property for when we're dividing, not multiplying as in property 1, but when we're dividing those quantities that have the same base. So again, they need to have the same a value, and when that's the case, you can subtract those exponents. So here you see we have 7 and 7, so that part is fine. And then we're going to subtract the exponents. 9 minus 10 gives me a negative 1. So we want to keep those 2 properties in mind, and we'll look at some examples in just a second. Okay, our third property, this one we've already looked at. This is the one that deals with the negative exponent, moving it up or down to make it positive. So we have dealt with that exponent property. All right, let's look at property 4. And here you have a to the n, and it's raised to the m power. And so you want to keep in mind that that means that you should multiply those exponents. Now, often students will take this property and this property that we had on the other screen and confuse them. All right, you want to keep in mind that this is 2 bases, bases are alike, you're going to add your exponents. This is multiplication right here, n times m. Right? And you can see it in this example, and we'll look at a few more in a minute, but 2 to the third squared is the same thing as 2 to the sixth. All right, when you do have an exponent on the outside of a parenthesis, you want to keep in mind that that exponent can be distributed to the terms inside as long as they are multiplied. All right, and so you can see that happening here. 7x in parentheses raised to the third power. This 3 is distributed to the 7 and also to the x. 7 to the third is 343, and then you have x cubed. All right, and our last property does a very similar thing, but with a fraction. It says that if you have a fraction and you have a power on the outside of a parenthesis, that power will apply to both terms. And you can see it's a to the n, b to the n. Or as an example, this 2 would apply to the 3 and also to the x. Okay, so let's try some problems here and see if we can work these out. All right, so we want to simplify the following expressions. We want to write the final answers with only positive exponents. All right, so let's begin with part A. Part A has this expression, 17x to the fourth plus 5x squared plus 2 in a set of parentheses, and it's raised to the 0 power. Okay, so what did we say about expressions being raised to the 0 power? That anything raised to the 0 power is always equal to 1. And so there's really very little for me to calculate here. We're just going to raise that to the first power. All right, what about for part B? All right, so for part B, we know, well, let's just sort of look at it a little piece at a time. Let's look first at this part. So we know that when we have an exponent on the outside of the parenthesis, that it applies to all the terms inside as long as they are multiplied or divided. And we apply it by using multiplication. So I'm going to take this -1 times that 2, and that part's going to become x to the -2. And then I'm going to do the same thing for the y. -1 times 3 is going to be y to the -3. All right, I'm going to leave the z to the -2 alone. And I'm going to leave the bottom part alone for right now. Now, in most cases for students, it is easier to work the problem if the exponents are all positive. So let's take a minute and move things around so that all of our exponents are positive, and then see what we're left with. All right, so there's my fraction line. Let's take these things one at a time. All right, so x to the -2 is in the top part of the fraction with the negative exponent. We're going to move it down. It's going to become positive. Y to the -3rd is in the top part with a negative exponent. We're going to move it down. Same thing here. Top part of the fraction, but it has a negative exponent. We're going to pull it down. That takes care of all 3 of them on the top. We've moved them all to the bottom, and they now have positive exponents. Okay, this one, x to the 3rd, it is positive, so we're going to leave it in the denominator right now. The z to the -3 needs to come up so that it has a positive exponent. Okay, so now let's look and see if we can combine anything. In the denominator, look at your x's. You have an x squared and an x cubed. We have a property, remember, that says if your bases are alike, meaning they both have the x, that you add your exponents. So x squared times x to the 3rd becomes x to the 5th. And I'm going to write the rest of it down as is. Now, the only thing left is the z part because we have z's in the top and we have z's in the bottom. So I'm looking very specifically at only this part right here. Remember, our property says that if we have a setup like that where we have the same base in the top as in the bottom and we want to try to combine them, we combine them by subtraction. So this part becomes z to the 3 minus 2, which would be z to the first. And then I'm going to rewrite the bottom part. Now, technically, we don't tend to write z to the first. We just write z, and so we'll leave it like that. All right, so our final answer is z over x to the 5th, y to the 3rd. All right, so let's look at part C here. Okay, so again, taking it piece by piece, let's deal with the top part of the fraction first. This -3 exponent, remember, is going to be applied to everything inside the parenthesis. So we're going to have -2 now raised to the -3. That's the first one. All right, then we're going to take that -3 and we're going to apply it to that +3. Remember that we do that with multiplication. So it becomes x to the -27. No, I'm sorry, it becomes x to the, we're multiplying. 3 times 3 is going to give me 9. Sorry about that. All right, and then we're going to take that -3 and multiply it times that -1. So that's going to be y. -3 times -1 is going to be +3. All right, let's look at the denominator now that we've simplified on the top. What's going to happen here? We have 18x to the -3 in parentheses raised to the 0 power. That is equal to 1. So we have a 1. And then we have this -2 as an exponent on an xy. So we're going to have x to the -2, applying it to both terms, and y to the -2. All right, so let's see what we have now. All right, so let's work first on getting exponents to be positive, just like we did in the last example. So I'm going to start here with this top part. And it's in the top of the fraction. It's got a negative exponent, so I am going to move it down. That'll make the exponent positive. We have an x to the -9. Move it down. Becomes x to the +9. We have a y to the 3rd, which I'm going to leave in the top. It's good to go. We have a 1, which I'm pretty much going to ignore because I know that multiplying by 1 is going to give me the same thing anyway. I have an x to the -2 that I'm going to pull to the top, making it positive. And a y to the -2, which is going to come to the top as well. All right, so let's look at what we've got here. We've got 2 y values. Remember, bases are alike. You're going to add those exponents. So we're going to have y to the 5th. And I'm going to pretty much rewrite the rest for a minute. What happens to -2 to the 3rd? That's going to be like -2 times -2 times -2. So that's going to be -8. All right, so let's deal finally with this part. Now, remember what we said about that situation. We said that that's a subtraction problem. When your bases are alike, it becomes x to the 2 minus 9. So that is going to give me an x in the top. It's going to give me an x to the -7. All right, and again, we've just created a negative exponent that we're now going to drop to the bottom. So I have y to the 5th alone on the top, -8, x to the 7 on the bottom. And we're done with that one. All right, our last example. We have 7xz to the negative 2 in parentheses, which we're squaring. And we have 5x squared y in parentheses raised to the negative 1. So let's begin with this first one, and we're going to distribute our power of 2 to all three terms there. So it's going to become 7 squared, x squared, and z, remember that we multiply to the negative 4th. We do the same thing on the second set. We're going to distribute the negative 1 power to every term inside the parenthesis. So 5 to the negative 1, x to the, remember you're multiplying, negative 2, y to the negative 1. All right, let's create a fraction and let's make sure that we have all our exponents positive. So one term at a time, the 7 squared I'm going to leave in the top. The x squared I'm going to leave in the top. All four of these terms have negative exponents. I'm going to drop all of these to the bottom. So z to the 4th, 5 to the 1st, x squared, y to the 1st. All right, so one thing that I notice is that I have an x squared in the top and an x squared in the bottom, which will cancel out. 7 squared is 49, 7 times 7. We have a 5 to the 1st, which is just 5. We have a z to the 4th, and we have a y to the 1st. And that's really all we can do with that one.